Again, welcome to Biostatistics 1. In these lectures, we're going to discuss about frequency distribution. We may go through how to organize our data using a stem and leaf plot, or sometimes called a StemPlots, and also frequency tables, and also frequency distribution, and also some other charts such as bar chart or pie chart. So our main objective is a stem plot, frequency table, and other charts. So first we start with the stem and leaf plots, which sometimes we call the stem plots. Here always start by looking at the data with graphs and plots. So here we're trying to say that anytime we have a data set, always we try to find a pattern or type of distribution of the data by using a graph or a plot, which is the visual representation of the data. One of the techniques we can use is what we call the stem and leaf plots. So a stem plot is a graphical technique that organizes data into a histogram-like display. Also, histogram is a graph which looks like a bar chart. So let's start with an example. Here we have an example of a sample random. SRS stands for simple random sample. Simple random sample. So we took a sample of 10 different ages of patients, and we list the ages in order. So the minimum age was 5, the maximum age was 52, and they are in order. So now we want to plot stem and leaf. So stem and leaf plot means two things. We have to have our stem value and also our leaf value. Always the stem value will be the leading digits, and then the leaf value will be the last digits. So here, this value is very straightforward. Since we have only 2 digits, our leading digit will be our stem. So here, in this example, we say the 10th place will be the stem value. So we start from 0, 1, 2, 3, 4, and 5. So our leading digit will be tens because this is 2 digits. Then the leaf will be our last values. So when we try and plot this, we get 0, 1, 2, 3, 4, 5. We wrote times 10 here to tell us that this leading digit, they are in tens. So 1 means 10, 2 means 20, 3 means 30, 4 means 40. Then we start with the leaves. So the first value we get was 1. We have 1 here, and the rest of the values are given. So this leaves value should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what this means is that we remember the first value was 0, 5. So we can say that in the 0, we put 5. In the 1 section, we put only 1. But in 2 section, which is the 20, we have 1, 4, 7, 8. Then 3, we have 0. Then 4, we have 2. Then 5, we have 0 and 2. So that should be our final solution. So here we can see that 0, 5, 1, 1, 2, 1, 24, 27, 28. I have 1, 4, 7, 8, which is 21, because the leading digit is 2. So 21, 24, 27, 28. We have only 31, so 3 and a 0. 42, only 4 and 2. 50, we have 2 values, 50 and 52, so we have 0 and 2. So in this section, again, on the right side of the vertical line is called the leaves, and the left side, which is the leading digits, are called the stem. We can plot this also horizontal. So horizontal will look something like this. Horizontal actually can give us the shape, whether it's a skew to the right, skew to the left, or there's no inner shape, or they are bell-shaped, normal curve. So how do we interpret the stem plot? The shape can be symmetric. If it's a symmetry, that means it's a normal curve or bell shape. Modality means we have the number of peaks. And number of peaks means the highest The high value can be more than 1, 2, 3. Kurtosis will tell us the width of the tails. Kurtosis normally tells us the steepness of the graph, that's why it tells us the width of the tails. Then departure will be the outliers. Maybe the outliers are data that are very small or very large. Also, we may have the gravitational center, which is the mean, but in stem and leaf, we always can find the middle value, which is the median. The median value will be the middle value. We also can interpret the range, which will be the spread of the data. So we can find the range. The range always will be the difference of the minimum and maximum value. We can also find the interquartile range. We can also find the standard deviation and variance for the spread, but this will be discussed in Unit 4 lectures. So let's start with our solution, the shape. The shape refers to the pattern when they're plotted. Here is the skyline of our data. So this is our data. Remember, we have from 0 to 5. 20, we have 4 values. 50, we have 50 and 52, 2 values. The rest are 1 unit. So we may consider the shape, we may consider 2 things here, at least 3. Is this symmetry? This doesn't look symmetry because we here move here. Modality is how many peak we have. Here is 1. Then also the kurtosis, the steepness. So this is an example of distribution shapes. Symmetrical will always be a bell shape. This is also a symmetrical, again, but normal curve is always a symmetrical. Here is a symmetrical, but it's not a bell shape. Then we may have a uniform. Uniform also is a symmetrical. Then a bimodal, we have 2 peaks. So we have 2 bimodals. Then we can positive skew. Positive skew means the mean value is greater than the median. Negative skew means the median value is greater than the mean. Then the bell shape means the mean and the median and the mode are the same, they are equal. So this is a unimodal. A bimodal, we have 2 peaks. And in the kurtosis, we say the steepness of the graph. So we can see medium, flat, and also skinny tails. So here we have a fat tails, a medium. So this is very difficult to judge by eyes. So kurtosis tells us the steepness of the graph. And you can see that the kurtosis changes based on the spread of the data, the standard deviation. Location can be the mean. So here, the highball method visualizes where the plot will balance. So we can sum values and divide by n. That will give us the mean. If I had all these values and divide by number of values, that will give me the mean. So median also, to find the median, we have to put the values in order. Then we take the middle value. If the values are size is even number, let's say here we have 10 values. So the middle values will be 2. So we take the number 5 and 6 position, and we'll find the average of them. So the average of 27 and 28, which divide by 2, will give us our mean. Our median, sorry, median. So for location for median, if the total value is a odd number, then we have only 1 middle. If it's even number, then we take the average of the 2 middle values. Also, to find the range, we find the difference of the maximum and minimum value, and that will give us the range, which also tell us the spread of the data. So this is a second example again for StemPlot. This time we have the decimal values. So it's up to us. Are we going to use the decimal, the whole number part as a stem and the decimal as a leaf? Yes, but the best way to solve this, since the decimal is 2 places, we can approximate it to only 1 decimal place. So for example, 1.47 can be 1.4. Or in this term, we say truncate. approximate means I'll make this 1.5, which also we can do that. The goal here in a stem plot is finding the shape of the data and possible the range. So few decimal places like 0.01 can make a big difference. So here they say we shouldn't plot the decimal. I change 1.47 to 1.4, then I'll make the whole number as a stem, the decimal number as the leaf. And that's what we have here. So we have 1.4, 2, we have 2.03, this is 2.06, we have 2.36. So I'll have 2.0 and 3. In 3, we have 3.4, 3.74, 3.78. So we use 77. So here we truncate each decimal last digit instead of approximate. And here it seems like we get a normal, close to a normal curve. So we say the center will be between 3.4 and 3.7. This will be odd even number 1, 2, 3, 4, 5, 6, 7, 8. We have 8 values, so the middle value will be 2. So it's to be between 3.4 and 3.7. The spread, of course, we find the range, the difference of 1.4 and 4.4. The shape is mode, and then we can see the data are close together, so there's no inner outline. This is another example with 25 data sets. The data already is in increasing order. But see what happened here. We look at the minimum value 14, the maximum value is 38. When we use the stem 1, 2, 3, since it's between 10 to 30, we can see that all the data are squeezed together. Especially 3 have so many values in 30s. 20 is also the same. So we can't find the shape. The shape doesn't look good here. So what we can do is that we can divide the 1 into 2. So we may have 1, 1, 2, 2, 3, 3 to again spread it a little bit. In this case, we may say, okay, the first one will be from 0 to 5. The second one will be from 6 to 10. And that's what we did here. We say 0 to 4 and 5 to 9. So we split it 1, 1, 2, 2, 3. We can see this gives us a good shape. This is like skewed to the left. Skewed to the left. So that's called a negative skew. It's skewed to the left. Skew to the left is negative skew. Skew to right is positive skew, because right is increasing and left is decreasing. So how many stem values? Again, this is again try and error. We can adjust it, but it should be somewhere between 4 to 12. And also, as they mentioned, try different stem multiply. Try splitting the stem as we did the last example. Look for most informative plots. So this is another example. We have 53 body weights of students. And we can plot it, but now we have the 3 digits. The minimum should be somewhere around 100. The maximum is 190, 260. I can see 260. So it's like 100 to 260. So we can decide to, again, use the first, since it's 2 digits, we can use the first 2 digits as a stem and the last digit as a leaf. So we multiply by hundreds multiply, so only 2 stem values. When I did that, what happened? I get only 100 and 200 because all the values are between 100 to 260. That doesn't look too good. The values all will be squeezed together, especially we have so many hundreds, so many hundreds. They are everywhere, only few 200s. Actually, it's like only 3 or 4 200s. So this will not look well at all, too broad. We get 1 line straight for hundreds. So we decide, okay, let's split it into 2. Maybe stay too broad, split it into 4. Maybe 4 will work. So let's see the next slide. They decided to split it. Actually, we use the split this into 10. 10. So we use 10 split because we start from 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Then 0 also to 26 because the highest value is 260. And this gives us a little bit equal shape. Then here we can see that 260 is like outline. Then you can see 1, 2, 3, there's nothing, there's no value. So 260 is like one value that is very large. Then we can find the location. Media will be around 165. The spread, of course, is the difference of the minimum and maximum. So from 100 to 260. This looks more better, and it looks like it's skewed to the right. And you have two peaks, one peaks and the second peak. So again, stem and leaf or stem plot, there's no specific regulation that you get correct answer once. And the goal is that you want to see how the data are distributed. So you can adjust the number of stems you have. This last example, if I use only 2 stems, I won't see any distribution. Most of the values are 100, and here we have 53 values. If I divide it into 2, still I won't see much because most of the values are 100. So if I have 100 to the next will be 15, still, so here we can see that we break it into even 10 parts because there's so many hundreds, like 50 something, around 50 hundreds. So this is, we can also use the SPSS application to develop the StemPlot. So next we move to a frequency table. The concept of frequency is counting. So if we say frequency of something means the total tally or the count. Relative frequencies correspond to proportion. So it's always the number of values in that category divided by total value. So relative frequency, again, is a proportion of some part. Cumulative frequency means we had the previous frequency, we cumulate it to the end. So cumulative frequency always equal to 1. So in frequency table, we're going to see frequency, relative frequency, then cumulative frequency. So this is an example. We have age of patients from 3 to 19. We look at the data. How many patients are 3 years old? We say 2. How many are 4 years old? 9. How many are 5 years old? 28. So when we count all the frequency, total will be 654, which means we have 654 patients. And their ages depends, like 19 years, we have 3 of them. 16 years, we have 13. Now, in order to find the relative frequency of each age category, we are going to divide the number of age we have in that category by the total. So 2 divided by 654 will give me 0.3. 9 divided by 654 will give me 1.4. So 5 years, we have 28 of them. So we divide 28 by the total, 654 will give me 4.3. So when we add all the relative, we should get 100% or 1. Then cumulative frequency, we are adding the previous one. So first is 0.3. Second, we get 1.7. Why? Because 1.4 plus 0.3. Next, we get 6. Why? Because 1.7 previously plus the present 4.3. So that will give me 6.0. So we had, at the end also, we should get 100% or 1. So this is the concept of frequency table. Sometimes we may have frequency table whereby we have to set the number of classes. Here, the number of classes here is from 3 to 19. So that will give us like 16 or so. Yeah, around 15. Number of classes is number of rows we have. So when data are sparse or group data into class interval, we can, by assumption, they say we should have somewhere between 4 to 12 class intervals. So classes can be uniform or non-uniform. Then the endpoint conversion, first class interval, if it's 0 to 10, we'll include a 0, but we will exclude a 10. So it will be 0 to 9.99. The main goal is that we don't want to have the same class twice, the same value in 2 different classes. Then we tally the frequency as we saw it. We calculate the relative frequency, which will be the proportion. Then we calculate the cumulative frequency. So frequency table will have 4 columns. The class, then we tally frequencies, then we find the relative frequency, which is proportion of each category. Then we find the cumulative frequency. So this is an example given to us. We have a uniform class interval table with 10 for the data of given. When we look at the data here, we have from 5 to 52. And the data are 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 data set, which we can see here. So we decided to make the class 10. From the class width have to be the same. So if it's from 0 to 9.99 here, then this have to be 10 to 19, 20 to 29, 30 to 39. So they have the same number of the width size. Now we look at the data set from 0 to 9.99, we have only 0, 5. We have 5, so it's 1. From 10 to 19, we have only 1, which is 11. From 20 to 29, we have 4, 21, 24, 27, 28. Then 30 to 39, we have only 30, so 1. 40 to 44, we have only 1. Then 50, it's supposed to be 40 to 49. It's a mistake, 40. You can see that when we go to 40 to 44, then we should start with 45 to 59. So this is 9, 40 to 49. The class width have to be the same. So if it's 40 to 49, stay 1 because we have only 140s. Then 50 to 59, we have 50 and 52, so it's 2. Then next we find the relative frequency. 1 divided by 10 is, the percentage, it will be 10% or 0.1. The next 0.1, 0.4, 0.1, 0.1, 0.2. When you add all together, you should get 1 or 100%. Cumulative frequency means we had the previous value. So first we start with 10. The next it will be 20 because we have present 10 plus previous 10. The next is 60 because we have a previous 20 plus present 40. Then 60 plus 10, 70. 70 plus 10, 80. 80 plus 20 is 100. So next we talk about a few charts here. The next is histogram. Histogram look like a bar chart. And normally the horizontal will be our classes. So we can turn the frequency table into histogram very easy. The reason why, because here histogram will have only frequency and the classes and the frequency. So the classes will be the x-axis, the frequency will be the vertical or y-axis. So here we can see the frequency from 0 to 4, and the classes we have 0 to 9.99, 20 to 29, etc. And in 20 to 29, we have 4, so we can see the bar go up to 4. From 0 to 9.99, we have only 1, so 1 bar. Next is 1 bar. Then 50 to 59, if we remember, we have 50 and 52, so it's 2. So histogram is a frequency chart for quantitative measurement. And x-axis will always be the class, and then the frequency, the total number of tally, will always be the y or vertical axis. A bar chart and a histogram, they're almost the same, but we can see there's interval here. Why? Because in bar chart, we use qualitative data, or we use the term categorical measurement. So here, for example, we have a pre-elementary, middle school, high school. Or if it's a number of cars, I can have red cars, yellow cars, blue cars. Then always the vertical will be our frequency. If I saw 20 yellow cars, then the bar will go up to 20. If blue cars are 3, then the bar will go up to 3. Here we are using a school level, preschool, elementary, middle, and high school. So histogram is for quantitative data using the class width, and then vertically it will be the frequency, the total tally. Then bar chart, the x-axis will be qualitative data or categorical measurement. So this is a pie chart. Here again is our frequency table. From this, we can come up with a pie chart whereby we may have the pie chart will be the relative frequency, the percentage of each category. So this is again a frequency table with labels. And then here we can see our pie chart, each percentage. And the elementary school is more. And we can see the preschool section. Pie chart can be any number of categories. And this will be our conclusion of Unit 3, again, lectures. And this lectures is on frequency distribution. And we discussed about how data is organized using the StemPlot, frequency table, and also chart, histogram, pie chart, and the bar chart. Again, wish everybody the best. Thank you.